All right, guys, welcome back. Today we're going to be diving into system hardening. So, if you imagine cybersecurity as building the fortress, we've talked about the walls and the moat. Now we're going to talk about the layout of the castle itself. So, how do we make sure that the internal systems are tough enough to withstand an attack if someone gets inside? This is what system hardening is all about. So let's talk about how this works. So, as always, this is going to directly align with the CompTIA Security Plus objectives. Expect to see questions on the exam about securing operating systems and knowing the difference about unneeded services and malicious ones. And how do we manage the configurations of each of these at scale? So here's going to be our roadmap for this chapter. We're going to start covering, well, changing default configurations. We'll look at restricting applications and removing all of those unnecessary services. We're going to define what a trusted operating system is. We'll talk about the never ending cycle of updates and patches and patch management practices. We'll talk about group policy for Windows and SE Linux for Linux itself. And then we'll wrap up with data encryption and secure baselines. So let's start off with the easiest win, but the most common failure changing default configurations. When you pull a device out of the box, whether or not it's a router, a server, or even an IoT device, it's usually designed for usability and not security. We want to make sure that grandma is able to use the device without complaining that it's too hard to use and returning it to the store. So, why? Why is this the first step? Well, because the bad guys themselves have the same user manual as you do. If you leave the default username as admin and the password as password, you are practically inviting them in. Default configurations are public knowledge, and scanners like Shodan look specifically for devices that have not been changed. If you haven't changed the defaults, you are low hanging fruit and a prime target for the attack. So let's talk about restricting applications. This is exactly what it sounds like. We need to control which software and applications are allowed to run on a system in a secure environment. And are the users able to install whatever they want? I hope not. Let's make sure that they're not able to do so. So let's think about the risk here. If only it only takes one user installing a free PDF converter, which is actually a keylogger, to compromise the entire network. So, aside from preventing malware itself, we also want to prevent shadow IT. This is where employees use unauthorized software to do their jobs because they think it's faster. It creates licensing issues, security holes, and data leaks that we don't even know that's happening within our system. So, what are some of those methods for restricting applications? We generally have two approaches. Here we go. We've got blacklisting, which allows everything except bad programs. It's hard to maintain because new bad stuff comes out every day. Or we have whitelisting, where we deny everything except for what is explicitly allowed. This is much more secure, but will require more administration overhead. But this is the level that we normally will see within our environment, is we'll have a whitelist because we only want the software that IT has approved to be installed within our network. Now, for the best practices, we always are going to use the principle of least privilege. Let's remove the rights so users can't install software, use application control solutions like AppLocker or Carbon Black, and this will help us implement, well, those whitelists and make sure that they're enforced practically. Now, moving on to unnecessary services. Every operating system comes with services running in the background. And a lot of these you probably do not need. So we probably want to disable those for multiple reasons. Some of the more common ones that you want to disable: if it's a server and it's a database, does it need the print spooler running? No. Does it need Bluetooth support? Probably not. And every service running, and because what we want to make sure is every service running is a potential entry point for an attacker. We like to call these attack vectors. If you're not using it, kill it. Turn it off. Now, the process involves auditing your ports and services. We'll use tools like Nmap to see what is listening. If port 80 is open on a machine that isn't a web server, you have an unnecessary service running, so let's go shut it down. So let's talk about what a trusted operating system is. A trusted operating system, this isn't just an OS you trust because you like the vendor. By definition, a trusted operating system, a TOS, is an operating system that has been designed and configured with robust security features to enforce a high level of protection for system resources and data. I like to think military grade. It meets specific government criteria for processing classified information. So we like trusted operating systems. They help us take the guesswork out of access control. They're going to assume the environment is hostile and protect data based on some of these strict rules and not just our user discretion. Whoops. Helps if I stop skipping slides. All right, so let's talk about the features that make a trusted OS. First is the MAC, mandatory access control. Unlike discretionary access control, where I can share files with anyone, in Mac, the system decides who can see what based on the security clearance labels. And remember, I like to use the word military when I think about Mac. Military access control, how do they function? Now, multi-level security is going to help us because it's going to let us have top secret and unclassified data on the same machine, and ensures that unclassified users can never read anything above their permission level. We may have enhanced auditing and logging so that every access attempt, success or failure is logged so that you can hide your tracks. So a TOS is going to make sure that nobody can hide their tracks. We may also use RBAC, role-based access control. You don't just give permissions to Bob. You give permissions to manager, and Bob is assigned to manager. They might be tamper resistant. Even if an attacker gets in, the core security configurations are locked down so tightly that they're difficult to change. We'll also see integrated encryption, so the file system itself may be encrypted by default. They're also going to have patch and update management built right into their operating system, right into their lifecycle. Now, examples could include SE Linux, Trusted Solaris, which is also another Unix operating system, and even SE Android for our mobile devices. These are versions of standard operating systems that are hardened to meet specific criteria. So some of the best practices here is use a trusted operating system when you are handling highly sensitive data. For a standard web server, it might be overkill, but for a database holding social security numbers, it might be a strong consideration to use. All right, let's shift gears to the bane of every IT admin's existence, updates and patches. This is the most critical component of maintaining security. And so we need to understand there are many types of patches as we go through here. We could have hot fixes. These are quick fixes for specific issues. We may have just a generic patch, which is just general code fixes. We may have service packs, which are normally large bundles of updates. Or we may even have security updates, where they specifically address certain vulnerabilities that are already found. Now, the challenges are real. If you patch too fast, if you might break the application. We call this regression. And if you patch too slow, you might get hacked. So this is definitely a balancing act when it comes to security. So what are sound management practices? We should always test first because we don't want to deploy into production first. Let's test it in a lab. We should schedule our updates, usually during a maintenance window when the least amount of users could be affected. We may want to verify that the patch is actually installed. Just because it said it installed, did it truly install properly? And then lastly, we should automate. We need to automate because I don't know about you, I'm not going to patch 1,000 machines manually. That takes way too much time. So for the Windows world, our best friend is going to be group policy. Group policy is a powerful feature of Microsoft Windows that allows administrators to centrally manage and configure operating systems. This could include our applications and even all of our users across an Active Directory environment. Basically, it's how we push rules to everyone at once. So why do we use a GPO? Because manual configuration is impossible when at scale. So we need centralized management. It's going to give us one console to rule them all. It's going to have security enforcement. I can enforce everyone to have a 15-character password all from one screen. It can also guarantee consistent configurations. Every laptop will look and act the same. We can use it for automated software development and updates. And I can install things like Chrome on 500 computers while I drink my coffee. And it all handles user and device restrictions like disabling USB drives to prevent data exfiltration. So there are a couple key pieces of group policy that you probably should know about. The first one is going to be security settings. This is where we set the password policies and account lockouts. We can have software restriction policies, the old school way of blocking specific exe files. We normally don't use it this way anymore, just know that it exists. We can do group policy preferences. These are the settings that are set by default, but the user can change later, like let's say the desktop wallpaper. Whereas a policy is forced, it cannot be changed by the user. So you can actually force the policy on a user to prevent them from changing something. We have user and computer configurations. And this is normally split into two different pieces. You'll have computer that applies to the hardware no matter who logs in. And then you'll have the user, which will follow the person no matter which computer they use. We have administrative templates. There are thousands of admin templates that are built in for Windows components. We have password and account login policies. This is probably the most common GPO, such as minimum password age, complexity, maybe their history. And then we have auditing and logging, which tells Windows to record specific events, like maybe failed login attempts, to the event viewer, and sometimes even push it into what we like to call a syslog server, a centralized location to store all of our logs. For the Linux side, we have what we call SE Linux. Security Enhanced Linux is a security architecture integrated into the Linux operating system. It provides a mechanism for enforcing fine-grained access control policies. This was originally developed by the NSA. Why do we use it? Well, because standard Linux permissions, read, write, execute, they're normally not enough. SE Linux confines these services into a more specific policy-oriented system. If a hacker compromises our web server, SE Linux will prevent that web server process from reading your password file. We have a couple different modes of SE Linux. The first one is enforcing. This is where the policy is active and blocking violations. This is where you want to be. We have permissive, where it's going to log all our violations, but it doesn't stop them. Great for troubleshooting. Or lastly, it could be disabled, which is turned off entirely. Don't do this. Now, some best practices for SE Linux. Don't just disable it because it's annoying. Learn how to write the policies or use booleans to adjust it. Troubleshooting is hard, but the security value is immense. So definitely use SE Linux when you can. Now we're going to wrap up with security baselines. A secure baseline is a set of predefined standardized configurations that serve as a foundation for the secure operating system, applications, and networks within an organization. Why do we use baselines? Well, they're important. They give us a gold image. If you know exactly what a healthy, secure system looks like, it's much easier to spot when something is wrong. Now, a baseline could include things like firewall settings, patch levels, OS configurations, required software. Just think of it like your standard build. What do you put on every one of your systems to create a baseline across your network? Now, some of the best practices, we do need to update our baselines regularly. So as software changes, your gold image needs to change. We should monitor it for configuration drift because systems will slowly move away from our baseline over time. Okay. All right. So that's the end of this chapter here. So we're going to then move on to the next chapter, which I think is 21. We're getting closer and closer to the end of the Security Plus. I hope that you guys are starting to feel familiar with the Security Plus terminology. I would say about a third of the test is terminology. There's a ton of acronyms, alphabet soup on this test. So if you're having a hard time with terminology, make sure you review your flashcards and make sure that you understand what the terms mean, where they're used, and, well, could you describe to your grandma if you saw it in the wild? All right, that's it for this chapter. I'll see you for the next one.